Alright, in this video, this is going to be the highlights from my first TEAS Math live session that I held in my Facebook group. I did this on October 26, 2020 at 8:30 p.m. Eastern Standard Time. If you are not a member of that group, please consider joining. You can find a link to that in the description below. But this was a live video. I was chatting with students as I was working out math problems. Now, this video does have some link to it. We cover several different math problems ranging from geometry, translating expressions, quadratic equations, and a little bit more. Not only that, I will show you how to navigate my website very quickly by searching for keywords. And then I'll show you something very similar to search just my YouTube channel for specific videos. So sit back, check it out. There's a lot to check out from this first live session that I did in my Facebook group. And without further ado, let's go ahead and get started. I'm going to give folks a few more minutes to come on in and join, and then we'll dive into some math problems, and I'll show you some other stuff over at my website as well as my channel. All right, so it's 8:30. We're going to go ahead and get started. For those of you who just are joining this group, if you don't know much about me, or maybe some of you who have been in this group for a while, or you've been following my YouTube channel, my name's Brandon Kraft. I've been a math instructor for 15 years. I taught high school for 4 years, and I've been teaching college level mathematics for the last 11. During this time, I would say probably for at least 8 or 9 years, I've been teaching TEAS math prep courses at the college I work at. And over the past 4 years, I've just started doing a lot of YouTube stuff. I have a website devoted solely to that, one spot at my website. So a little welcome. I'm going to tell you a little bit about me. I'm going to give a few more minutes for folks to come in, and then we will be looking at some problems right here shortly. The ones that I have set up tonight, let me go ahead and show those to you. We are going to do, and this is based off of feedback from you all. We're going to look at solving some quadratic equations using the square root method. And here we have two examples, and then also I'm going to share this entire file with you all at the end of the session, and you can actually go find some other videos. For example, that guy right there will take you to solving quadratic equations using this square root method. But this was one question I did see in the group. And then we're also going to look at a rectangle problem. I'm going to show you how you can quickly search for things at my website or on my channel for these ideas too. Notice down here we see proportions. Other things, a rectangle problem. I've seen this problem I don't know how many times, 20, 30, 40 times over the past 5 or 6 months with the pandemic. So this is a popular question, and I think this actually comes, or something similar comes from one of the practice tests that ATI gives you. So I have an additional video there, something somewhat similar. And then we have this problem right here. I think I've seen this several times in just this group over the past few weeks. And I have that exact video over on my YouTube channel. Based on time, based on feedback, we will actually do other stuff as well. But for now, let me tell you a little bit about me as more folks come in. So here's my website, bcraftmath.com, and just a little bit about me. I already told you I've been teaching for 15 years. I'm married, and my wife and I have a 5-year-old. He just started face-to-face kindergarten this past week, so that's pretty exciting. Other things about me, I'm a gamer. I like to grill good food, obviously doing math, making tutorial videos, and we do have a dog. So we're one and done when it comes to kids, but we do have a dog as well. We like to swim, I like to mountain bike, and we like hosting and having friends over for cookouts and get-togethers and whatnot, as you can see there. And then there's my license plate. I thought y'all might want to see that. So a little bit about me there, and then if you've been to my TEAS page, that's this here, and I just gave this a facelift recently. I have these little images here that you can tap on. And so, for example, for those of you who are just getting started with the math portion of the TEAS, clicking on those two things right there give you a summary of what I have available. But let me show you this as well. I mentioned navigation made simple. What do I mean by that? Navigation made simple. If we go back to my page here, and on a Mac, if I hold Command and tap F, I want you to notice what pops up here. It's a little search menu. On a Windows computer, you're going to have to hold Control and tap F. But once this little thing pops up, you can search this TEAS math page. For example, let's look up proportions. So I don't know if you can see that, but I did type in proportions and it says 1 of 6. You can actually use the arrow to go through all of these various spots where I have proportions at. This works for anything. Geometry, for example. So you can go through the spots where I have geometry. If you want to look for equations, look at that. Equations pops up 15 times in this single page. So that's where you can get quick things for videos. Also at my YouTube channel as well, if you go directly to my YouTube channel, make sure you listen to this. Right here, you have this little magnifying glass. And this will search just my page, just my YouTube channel. It won't search the entire YouTube. So for example, if you're looking at, let's type in solving quadratics. And let's see what happens when we do that. Check it out. That's one of the examples that we're going to look at tonight, solving quadratic equations using the square root method. So you can search my channel, or you can use the little search feature, Command F or Control F, to actually do that. Any questions so far? We're getting ready to jump into some math right here in a second. I'm just going to check the feed and see how everything is going. I'm going to look at some comments. Give me a second. So again, we do have a little bit of a lag. There is about a 20 to 30 second lag versus me talking and you actually hearing and seeing what I'm sharing with you. So there is going to be a lag there. I'm pretty sure for now on, I'm probably going to stick with Google Meet or Zoom because that is instantaneous versus doing it this way. But I wanted to give Facebook Live a shot as well. All right, so I showed you the YouTube channel. I showed you the website. Also over at my website too, I do have a workbook and a multiple choice sample that you can try. This is underneath the store tab, but you have the workbook, you have a free sample multiple choice quiz, and then a full one. And this one now has over 100 questions on it. I'm updating it all the time, but that's a couple of things that I have available outside of the free resources. The majority of what I have, over at my TEAS website, it's free. So just want to throw that out there. And now I think it's time for us to do some math. I mentioned earlier the problems that I'm going to do here. This entire document that you see here on the screen, I will save this. I'll add it to the group this evening. And then what I'm going to do probably tomorrow is I'm going to get you all to fill out a survey, a Q&A survey based on your experience tonight. So I'm going to stop there and just give you all a second to type in any questions or comments that you may have. Thanks, Nelly. I appreciate it. She said the website looks good. I just did give it a facelift recently, as I mentioned, to make it a little bit easier to navigate. Because there's over 100 videos, 100 free videos there, free practice tests, tons of free resources. And it got a little bit cluttered, so I had to give it a little facelift. But thanks again, Nelly. So what we're going to do is we're going to go ahead and jump into some of these math problems, the ones that I showed you earlier in the stream. And the first one here is we're trying to solve quadratic equations using the square root method. Now, before we actually jump into this, I just want to motivate the idea. Let me drag this stuff up here. And let's just suppose we had x squared is equal to, let's say, 16. So x squared equals 16. This is an equation. We're trying to find some number. What number can we square to get 16? And some of y'all may be thinking 8, and that's not correct. Now 8 times 2 is 16, but 8 squared, that's 8 times 8, that's 64. One of our numbers will be 4. Think about that. If you take 4 and you plug it into here, 4 squared does give you 16, but that is not the only answer. If you take a negative 4 as well, if you take negative 4 and you plug it into x, negative 4 squared means negative 4 times negative 4, you get 16. So, we want to be careful. When we square something, we're not multiplying it by 2. When we square something, we're actually multiplying it times itself. Now, how can I show you this in a not so formal fashion is something like this right here. We're trying to get this x by itself, and the way we get rid of this squared is we take the square root of both sides. The opposite of squaring is to take the square root. Just like the opposite of addition is subtraction. The opposite of multiplying is division. The opposite of squaring something is to take the square root. Now, what you're going to have to remember if you see this question on the TEAS is when you take the square root of 16, just don't forget that it can be two answers, a positive 4 and a negative 4. So with that said, let's jump into this first example. It's a little bit more involved. Let me slide this over here. So this first example, we're taking some number plus 3, then we want to square that whole daggone thing, and we want to get 25. Now I mentioned the opposite of squaring something is to take the square root, and that's how we want to get rid of this. The opposite of squaring is to take the square root, so I'm going to do that to both sides. And all that's really going to do, the whole point of us doing that is to get rid of that squared. And taking the square root of something squared does that. It gets rid of that squared. So that leaves us with x plus 3 on the left-hand side, and this can be equal to 5. The square root of 25 is 5. However, remember, we can have a positive or a negative. So I'm going to write out a second equation. X plus 3 is equal to negative 5. So essentially, we're taking the square root of 25. That can be 5. 5 times 5 gives you 25. Or it can be negative 5, because negative 5 times negative 5 does give you 25. Now we have to solve each one of these separately. We're going to do the same step here. We're going to subtract 3. We're just solving an equation. And we're subtracting because that is the opposite of adding 3. The 3's cancel out, and we'll get x equals 2. So let's hang tight on that one, and let's solve this one as well. Be careful with your signs. Subtracting 3 from both sides. The 3's cancel, and we get x equals, now be careful here, negative 5 minus 3. Some people will say 2, negative 2. Neither one of those are right. Minus 5 minus 3 more is minus 8. These are our two answers to this first example. Now, let's put the brakes on. Let's talk about this a little bit more. I want to make sure you understand this. Check it out. If we go back to our original problem, this was our original problem before we did any work whatsoever. If we take this answer and we check our work, replace this x with a 2, and let's work it out. 2 plus 3 gives you 5, and then when you square 5, check it out, you do get 25. Therefore, 2 is a valid answer. Let's do the same thing with negative 8. If you take negative 8 plus 3, negative 8 plus 3, that is negative 5. And then if you square that, negative 5 squared means negative 5 times negative 5. And check it out, you do get 25. So I've seen these types of questions pop up quite often in Facebook groups, comments on videos, messages on my website. And that's why I did make a video on this a while back. Check out that link. I will share this file at the end of this session, and you can go watch more videos on solving quadratic equations. Now, this question popped up in the group this week when I did ask, what's some problems that are driving you crazy, or what are some problems you want to see me work out tonight? I don't think you're going to see one like this on the TEAS, but I've been told wrong before, like where I said, okay, I don't think you're going to see this, but it turns out the ATI, they did put questions I thought that wouldn't appear on the TEAS, they did put them on the TEAS. Roman numerals, for example. Roman numerals are not mentioned anywhere in the newer ATI study guides directly from ATI, but folks are still saying they're seeing Roman numerals on the TEAS test. But look at this one here. So it looks very similar to what we just did. As a matter of fact, the only difference is that over here we have 25 and here we have 3. Now things are going to get a little bit messy, because if we follow the same steps, let's get rid of this squared by taking the square root. We need to do this to both sides. And just like a while ago, we have x plus 3 left over on the left-hand side. But here's an issue. The square root of 25 was nice. It was either positive 5 or negative 5. The square root of 3 is ugly. Here's what I mean by that. Let me just pull up. Now, unfortunately, you cannot use this fancy calculator on the TEAS, but if we look at the square root of 3, it's an ugly number. So what do we do with it? Leave it alone. You just leave it as the square root of 3. So therefore, I'm going to say, hey, the square root of 3, since it's ugly, I'm going to leave it like that. Now, we did say the square root of 25 was 5 because that's a nice square root. But let's not forget, we have a positive answer and a negative answer. So I'm going to write out the equation again, and I'm going to say, hey, it's equal to a positive square root of 3, and now we have a negative square root of 3. I know this looks weird, but the only reason I'm leaving them there is because it is an ugly number. It's a decimal that just keeps on going. But now, very similar, what we're going to do is we're going to subtract 3 from both sides. They cancel out. And you may say, okay, how in the world do I do this? There's nothing that you can really do here. The only thing we can really do is we can say, hey, all right, square root of 3 minus 3. You cannot combine these together. And that's a whole nother subject in and of itself, is working with radicals correctly. But this is as simplified as we can make that answer. Now, very similar for this one, if we subtract 3 from both sides, again, the 3's cancel out. So we're going to have x equals, we cannot combine this into one term, so I'm just going to write negative square root of 3 minus 3. These are our two answers for this second example. Now I'm going to flip back over to the group. So, okay, Nellie's saying that she did see this problem on her TEAS back in September. I'm looking through some of the questions. Thanks for the kind words, folks. I really appreciate it. Fernanda, I do one-on-one tutoring as well. We can talk about that at the end of the session. Watching videos, how much, okay, so Nicole St. Clair says, how much studying should we do before taking the TEAS exam? That fluctuates from student to student, depending on how comfortable you are with a certain subject. For example, if I were to take the TEAS, I would not study for the math, but I would study my tail off for the anatomy portion or the chemistry stuff because I'm not specialized in that area. My grammar is not the best, so I would have to study harder for those things. So there's no universal answer there. How long should you study? But over at my website, again, what I mentioned here, just getting started. Check that video out and look at this right here. This is a simple document without the clutter, and basically it's just giving you some pointers on preparing for the math portion of the TEAS. So it's not as much information, but these are all links. You can click on them and go to various pieces there as well. So that's it for solving quadratics with the square root method. I did get some requests from you all about proportions. This is a proportion, and it's a word problem. A lot of students will tell me, hey, I struggle with word problems. Word problems is very, very, very broad. There's so many types of word problems. But from my experience working with students, a lot, not all of them, but a lot of problems on the math portion of the TEAS, if they are word problems, you can probably solve it using a proportion. With that said, let's look at this example. We have a rectangle. It has a length of 2 5/8 inches and a width of 1 1/4 inches. If the rectangle is enlarged, so we're making this thing bigger, and its new length is 7 inches, what is the new width? So we have an old length and an old width before we enlarged it. And this is a common thing. When we're trying to do some type of conversion, we're trying to convert the smaller rectangle to the bigger rectangle. Conversions. There's so many things that you can convert. You can convert hours to minutes. You can convert feet to inches, yards to feet. There's so many things you can convert. Proportions are good to use for those particular examples. So watch what I'm going to do here. I'm going to say 2 5/8, and I'm going to put that over 1 1/4. So what did I really do here? Up top, I put my length, and down here at the bottom, I put my width. Now, there are so many ways that you can set up a proportion and still set it up correctly. You may set it up differently than what I'm doing here. And actually, if you check out my videos on proportions, you'll see where I do mention there's more than one way to set up a proportion. But what I want you to notice is that I do have my length at the top, my width at the bottom. Now, when this rectangle was enlarged, we have a new length of 7 inches. Since I put length at the top in this fraction, I want to put the length at the top in this second fraction. So that new length is 7 inches, and we're trying to find the new width. So this is what we're trying to find, the new width, and I'm putting an X down there. Now, a little fun fact, let me load up a basic calculator. You know, this looks a little more similar to what you may have on the TEAS. It's not identical. But if we look at some of these mixed numbers, here's a little tip for you if you didn't know this. I just typed in 5 divided by 8, and I got a decimal. Now, this is helpful if you don't want to multiply mixed numbers or improper fractions. If you can get a decent decimal, like 0.625, and again, that came from 5/8, we can really rewrite this as 2 point, and what did I just say there? 2.625. That is the exact same thing as 2 and 5/8, 2.625. 1 1/4, think about money, 1 1/4 dollars, that's $1.25. And again, what you could do there, if you type in 1 divided by 4, it will give you the 0.25, and I'm just sticking that whole number of 1 out to the left of the decimal. This is equal to 7 over x. Now we can solve this by cross multiplying and dividing. That's the most common way, the most popular way to solve proportions. So cross multiplying, 2.625 times x is 2.625. And then cross multiplying the other way, if we take 7 times 1.25, this is where the calculator comes in handy. 7 times 1.25, we will get 8.75. With these two cross products, oh, and I forgot something, didn't I? I forgot my x. 2.625 times x is 2.625x. We set our two cross products equal to each other, and to get x by itself, we need to divide both sides by 2.625. That's going to cancel those two decimals out there, and when we do this, we're going to get x equals 3.333333333. It's a bunch of decimals. Now, here is a multiple choice tip. This threes keeps on going. So, just like earlier, I took these fractions and I converted them to decimals. Well, suppose your multiple choice answers are the following. A, let's suppose it was 3 2/3. B, let's suppose it was 3 3/10. C, let's suppose it was 2 1/3. And then D, let's suppose it was 3 1/3. Here is a good multiple choice tip right here. Since our whole number is a 3, I'm definitely going to cross out choice C because that whole number was a 2. The only other thing we have to look at is we need to look at the fraction parts. 2/3, 3/10, and 1/3. We want to see which one of these fraction parts gives us the 0.3 repeated forever and ever and ever. And the answer is D. Come to my calculator, and if I were to type in that 1/3, 1 divide 3, that's the only one that's going to give us that ugly decimal that keeps on repeating. Whereas if I take the 2/3, that's going to give us a bunch of 6s. And the only reason you see that 7 there, the calculator is rounding that last digit that is showing. But 2/3 is 0.6 repeated. And then if we look at 3/10, 3/10 is just going to be a single 0.3. So the only one that works would be D for that answer. Now, using that tip, we never had to multiply or divide mixed numbers or improper fractions. And that's something that you do want to be comfortable with, but we could actually dodge that in this particular problem. Okay, so I'm going to backtrack. Feel free to type some questions. I'm going to backtrack to this question. A student was asking, okay, Kathy Mary, does the x equals -8? The other answer for the 25. So yes, back here, these are the two answers. X is 2 and x is -8. We get two answers for that problem. And what I would encourage y'all to do again is check out this video once I share this document with you all right here shortly. So we did a proportion word problem, and now this one right here. I've seen this a lot. Now this problem down here, the video link is not similar, but geometry is very broad. Perimeter in this example, here's how I want to motivate y'all to think about this. It says let x represent the length of one side of a rectangle with a perimeter of 200. Write an expression that represents the area of the rectangle. So before we jump into this x junk, let's just think about this for a second. I'm going to make up some random number. Let's suppose that this right here is 40 units long, this length of this rectangle. Well, if that's 40 across this top part, this is also going to be 40 across the bottom part, right? Now, I know this looks longer, but here's the deal. If we take this 40 plus this 40, that gives you 80 for our perimeter, part of our perimeter, that is. Well, remember, the perimeter is 200, so we still have, 40 plus 40, that's 80. We still have an additional 120 feet left to go around this rectangle. And since these two sides are equal, this would have to be 60 and 60. Now hang in there, bear with me. I want you to check out what I'm doing here. If we come and find the perimeter of this rectangle now, 40 plus 60, that's 100. And then here's another 40 and another 60, that's also 100. So 100 plus 100 gives us that perimeter of 200. Now bear with me, I'm going somewhere with this, hang in there. I'm gonna draw another rectangle. They don't have to be drawn to scale. Let's suppose I made this 90 units long, and that means this one would be 90. So 90 plus 90, that's 180. That still leaves us with 20 additional units. And since we want to split that up equally, we would do 10 and 10. Find the perimeter. 90 plus 10, that's 100. Another 90, another 10. 90 plus 10 is 100. Another 90 plus 10 is 100. The perimeter is 200. Now here's what I want you to notice. I could sit here for the rest of the night and draw rectangles, but that would bore you to death. So check it out. If we let this be equal to x, or if we let this be equal to x, how could we use the 40 to find this 60? Do you remember earlier I said that these two would add to give us 100? These two add to give us 100. These two add to give us 100. These two add to give us 100. Well, here's what you can really do. If this is x, for this side here, we can take 100 and subtract whatever that number is. Check it out. If x is 40, 100 minus 40, hello, that's 60, right? If x is 90, check it out. If we take 100 and subtract whatever that x value is, x is 90, 100 minus 90, we get 10. Now we're bringing in the algebra. So we have a length of x and a width of 100 minus x. Now back to our problem. It says write an expression that represents the area of the rectangle. Well, to find the area of a rectangle, we take length times width. You would take this 40 times this 60, or you would take this 90 times this 10, or in more general terms, in terms of x, we would take not 40 times 60, we would take x times 100 minus x. And notice that would be the 40 times the 60, or the 90 times the 10, or any of those combinations. But since we wanted it in terms of x, that is the area of that rectangle. So that's it for that one. Now, this last one that I have here, this is, I'm not going to go over this one. I encourage you to watch that video because it's the exact same problem, but I have seen it pop up quite a bit. So check out that link once I share this document with you. And that's all I have. I don't mind spending a few more minutes. If you have some last minute questions, I definitely plan on doing this again, whether it be through Facebook Live or Zoom or Google Meet. I'm going to hush for a second, and I'm just going to let y'all type some comments. And again, it's going to take about 15 seconds for it to catch up, though. And it looks like that last problem was a little bit confusing. And you know, it's a tricky word problem because essentially you're trying to translate something. You're translating a sentence into an algebraic problem. So I would encourage y'all to try out this problem here. It is different. It's not identical, but it's still applicable. This was a problem that I received from a student, and I actually included this in my workbook as well. So for more examples like that, you can check out my channel, search topics at my website. If you have the TEAS Math Workbook, if you have my TEAS Math Workbook, give me a shout. I can point out where you can look for those problems within the workbook as well. If this problem here is causing your head to spin, draw some more rectangles. Just play around with this. If I draw another rectangle, crazy, it don't have to be drawn to scale. If I make this, let's say, 80 units long. If this is 80, that's going to be 80. And if you take 80 plus 80, that gives you 160, right? 80 plus 80 is 160. If you take 200, our perimeter was 200, right up here. If we take 200, subtract 160, we get 40. And if you take 40 and divide it by 2, 40 divided by 2, this will give us 20. That means this side needs to be 20 and this side needs to be 20. But here's the moral of the story. Check this out. If you take this side and this side, add those together, you get 100, right? If you take this side and this side, add those together, you get 100 again. And the perimeter is still going to be 200. But we don't know, and that's the whole point to this one. We don't know if it's going to be 40 or 90 or 80 or whatever. That's why we call it X. We don't know what it is. The problem says let X represent the length. So we don't know what this number is. We're going to call it X. But remember, if we have 80, if we take 100 and subtract 80, we get that 20. Well, that's the same thing as saying 100 minus X. Granted, we don't know what that number is. We can always take 100 and subtract whatever this number is to find that other missing side. And again, back to the area of a rectangle, we're going to take the length times the width. That's why I'm taking this X times that 100 minus X. And I'm also recording this video as well, so I'm going to add this to my channel. You can go back and watch this multiple times to let that soak in. Or what I would encourage you to do too is look for some keywords at my website. Translating. Check this out. If I go back to my TEAS Math page and I search, if I type in translate, or I can just put in TRANSLA, it appears 6 times on my channel, on my website. And notice, translating words to equations. Let's see what some of these other ones are. Translating a perimeter word problem. I think that was the one that I have linked in the file. Translating words into expressions, equations, and inequalities. So you can see that this does pop up quite a bit. A tougher example of translating words into equations. So I would highly encourage you to go back, have a look at those for some more practice, because there's not one set way to do translating problems. It depends on whether it's geometry or an equation thing. And let's see. Okay. I'm arranging numbers in order from least to greatest. I see that question. And putting numbers in order. So I'll tell you what I'm going to do. I'm going to add a page here. Putting numbers in order. And what I'm going to do before I upload this file is I'm going to put links. I think I have 3, maybe even 4 videos on that exact topic, putting numbers in order. So I'll be sure to put links to those videos right inside of here once I share this file. Okay, so television problem. I'll tell you what, we're going to end on this one. So I'll be sure to go back and put some putting numbers in order, some links to some videos there. And I'm going to finish with this question from Carrie. If I'm not pronouncing that right, I apologize. But here is that question. So let's end the night on this one. Television is discounted 20% in a sale. A shopper has a coupon for an additional 15% off. Which of the following is the total percent discount from the original price of the television? 35 is not correct. the television is discounted 20% off, and then the shopper is going to apply an additional 15%. We cannot add these percents, unfortunately. Now, let me show you what I'm going to do here. Let's suppose the original price of the TV was $100, a cheap TV. Why did I pick $100? Because it's real easy to work with percentages. Watch what I'm going to do. So let's suppose the original cost before any sale was $100. If we're going to get 20% off, what we can do there is you can use 20%, you can use a decimal there, D2P, and you want to find 20% of, that means multiply, of $100, because that's the original cost. And if you find 20% of 100, that's going to be $20. Now be careful. This is not how much the TV is on sale for. This is the discount. So right now, the sale price is going to be equal to $100 minus that $20 discount. So we're talking about $80 for this TV with a 20% discount. But now we have the next part. A shopper has a coupon for an additional 15% off the sale price. So the sale price, $80, the shopper, and whoops, actually deleted something. There we go. So sale price, $80, 15% off of that sale price. So let's find 15%, 0.15, that's our decimal. Of means multiply the sale price. If we find 15% of 80, let me just multiply that out. That's going to be an additional $12 off. So the sale price with the coupon, the sale price was 80. The coupon gives us an additional $12 off. And if we take 80 minus 12, that is going to give us a total price, including the sale and the coupon, of $68. Well, $68 versus the original $100, 68 out of 100, 68 is the price we're going to pay for the sale with the coupon out of 100. Again, 100 was the original price that I said. And if you divide this, we do get 68%, which that decimal is 0.68. Now, is that our answer? Let's read the question. Which of the following is the total percent discount from the original price? This is what we are paying. We are paying 68% of the original. The question doesn't say what percentage are we paying. What percentage is our discount from the original? So 100% minus the percentage that we're actually paying. We're paying 68% of the original. The discount that we're getting off, the total discount that we're getting off, is 32%. Our answer is going to be A. That is a tricky one. Now, some of you may be thinking too, what if you didn't pick $100? Folks, what I would challenge you to do is come back here where it says 100, make up some other random number. Make up something crazy, $550. Come and find 20% of that $550. Subtract it off like we did here. Get a new sale price. Find 15% of that and then subtract it off. I guarantee you, you're still going to end up paying 68% of the original cost, which means you got a 32% discount because I subtracted the 68 from 100. I've seen this problem quite a bit. Very tricky indeed, but I hope that does help a little bit. So I am done. We've been up here for roughly, 45 minutes, give or take a little bit. But I am signing off. I hope you all take care, and I will talk to you all in the group. Have a good evening.